So one of the most basic methods for solving equations is using reverse order of operations, and that's what this particular problem here is going to use. We have a two-step equation where a variable is only occurring one time. Typically, if you only have the variable occurring one time in an equation, reverse order of operations can be used. So, order of operations, please excuse my dear Aunt Sally. And when you solve an equation, actually, let me start with this. When you simplify, you follow order of operations. However, when you solve, you take order of operations in reverse. So the first thing we end up getting rid of is addition and subtraction. So we have subtraction here. So we're going to get rid of addition and subtraction by adding 2 to both sides. Give me 3x equals 6. And then we get rid of multiplication and division. So opposite of multiplying by 3 is to divide by 3. So x is 2. Remember that you need to use opposites when you are canceling out operations, and your goal is to get x, or your variable, by itself. So in this equation, we're going to solve 10 equals 4, or m over 4 plus 2. Now you'll notice it's in a different order, but that shouldn't be that big of a deal. Focus on, hey, here's where the equal sign is. My variable is on the right side now, so that's where my focus, my attention is going to be. The 10 is by itself. We can kind of ignore that when we're deciding what to do. So over on the right side, we have two numbers. Now that I'm focused on the right side, we have the 4, which is connected by division, and the 2 connected by addition. Remember that when you go through and solve, we want to get rid of addition and subtraction first, so we're going to get rid of the adding 2 by subtracting 2. What we do to one side, we need to balance it out by doing it to the other side as well. So 10 minus 2 is 8, is equal to m over 4. To finish this off, a fraction always scares people, but remember, fraction is just another way of saying division. This is dividing by 4 with the way it's written. So the opposite of dividing by 4 is to multiply by 4. And 8 times 4 is 32. And the 4 is on the right side, will cancel out. So overall, we have m is 32. Okay. In example 3, we're going to solve the equation 6 minus b equals negative 11. Now this one is tricky for a lot of people. A lot of people have common mistakes that are made here. For example, the first common mistake someone might make is trying to get rid of the addition and subtraction, and they often add 6. Adding 6 doesn't actually get rid of this 6. This 6 is a positive 6. This minus sign is in front of the b, so the negative portion is actually with the b. When you do algebra, it's almost better to pretend subtraction doesn't exist and look at it as adding a negative. So if you look at it like that, you can definitely see that it's the b that's negative. So in order to get rid of the 6, we should be subtracting the 6 instead. So we're going to subtract 6 on both sides, getting rid of addition and subtraction first. The 6's cancel. Now the second mistake people make is when they do this left side, they just bring down the b and they leave it as b equals negative 17. Don't forget that minus sign is with the b. It's a negative b. So we need to make sure we bring that minus sign down. And that's the second most common mistake with this type of problem. To finish this off, we still have to get b by itself. Remember that there are some implied numbers in math. One of them being if there is no number in front of a variable, it's implied to be 1. So we have a negative 1b. So to finish it off, we'll divide both sides by negative 1, leaving me with b equals 17. And there we have it. So in this example, we're going to solve the literal equation AB minus D equals C. We're going to solve this equation for B. Here is where our B is. So we're going to focus on that. Now, this equation here is very similar to a two-step equation. Okay. In the same way with this two-step equation as my side example, I would add 7 to get rid of the addition and subtraction connected to my variable. Well, we have addition and subtraction connected to the variable with the minus D. That's how that D is connected to the B, which is what we're trying to solve for. So in the same way I would add 7 with a normal two-step equation, I'm going to add D with this literal equation. The D's are going to cancel out, just like the 7's would in the normal two-step equation I have off to the side. For the normal two-step equation that I have off to the side, I would end up with 2x equals 15. On the one we're trying to solve, the literal equation, we have a times b equals, well, unlike when we're doing a normal two-step equation, 8 plus 7, we could do that and it became 15. We don't know what c plus d is. They don't have values, and there's no way to really combine that expression. So c plus d is literally just c plus d. That's where the term literal equation comes from, is because the answer is often literally the steps that you did to find the answer. To finish this off, in the normal two-step equation, we would divide both sides by 2 to get x by itself, giving us x equals 15 over 2 as a fraction, or 7.5 as a decimal. For our literal equation, a is what's connected by multiplication to the variable we're trying to isolate. So we will divide both sides by a. Now, since there are two terms over here, they are treated as one entity. So when we divide the right side by a, we need to divide the whole side by a. Canceling out, leaving us with b equals c plus d all over a. You can also write this in another way by dividing each term individually by the a, essentially distributing the division through both terms, leaving you with c over a plus d over a. Either way is usually accepted as a final answer. Okay, in this example, we're going to solve this literal equation for y. So here is where y is at. Looking at the things connected to y, we have the 3 connected by multiplication, and we also have the 2x as a single term connected by addition. Multiplication is stronger than addition, so because they're connected to the variable we're trying to get by itself by addition, these two are treated as one thing. So we're going to get rid of the addition first. The addition is the 2x. That's what's connected to the y by addition. So in order to get rid of it, we are going to subtract 2x from both sides. Subtracting 2x will cancel. And again, 2x is one entity. And 5 minus 2x, we really can't do that. So 5 minus 2x is really just 5 minus 2x. Remember that you can't combine terms if they don't have the same variables in them. The 5 doesn't have an x, so the 2 and the 5 cannot be combined. And then to finish it off, y is still connected to something by multiplication. To finish getting y by itself, we'll divide both sides by 3. And since there are two terms on the right side, we'll divide the whole thing by 3, giving us with y equals 5 minus 2x all over 3. Or remember that you can also rewrite it as y equals 5 over 3 minus 2x over 3. And because of how this fraction is, you could also write that as 2/3 x. And depending on what you're trying to do with this, one form might be more beneficial than the other. But as far as the question that we were asked, both forms that we have here are correct.